Here we go. Unit 6, basic integration. So today, and Yannick called it before I was recording, that antiderivative means an integral. And since it's polynomials, maybe they even talk about some basic trig. And let me ask you a question. If sine, the derivative of sine is cosine, what do you think the antiderivative of cosine is?
Would it be like would it be like arc cosine or something like that? Or
No.
Or would it be like
No. Okay, I'll let you chew on this. When we say something's the inverse of the other, it's just undoing it, going back. If I say, if you're adding 2 to both sides, or if you're adding 2 to something, you want to do the inverse by subtracting 2, then what are you doing to get, it's undoing itself. So you get back to whatever you were adding 2 to, because you took away the 2 instead. Like when you got x plus 2 equals to 7, and you want to get rid of the plus 2, you do the inverse. You subtract 2 from both sides. So you end up with just the x equals to something, whatever you did on the other side. It was 7 plus 2, I guess. Was it, what did I write the first time? I said x plus 2 is 7? Right, so that subtract 2. So 7 minus 2 is 5, right? So it's just undoing what you had in the equation one step at a time. Oh, hello. Somebody called and said you were coming. Okay, so the first half is no calculator. Well, you already did that one.
I need the second half.
I didn't grade it though, but it's okay. I forgot you did part.
can I go to the restroom?
Sure, since you worked so hard on redoing a free response problem.
Thank you, sir. I appreciate it. Why is there stuff in the way?
I don't know, is that your stuff?
No, it's Thomas's stuff.
Oh, and that's funny. Thomas puts his stuff way over there and he sits over there. All right, let's get started. If you had to explain to someone how to find the derivative of polynomial type function, what would you say? Polynomial. In other words, p of x equals to some constant, x to the 5 minus a different constant, x to the 3rd minus another constant, x, and to the 1st, and then maybe plus just another constant, a to the a4. So how would you tell somebody to find the derivative of a polynomial? In words. Don't care. I don't care about the a's and the x's. Just what do you say in words? How do you find the derivative of this first part?
Bring the power rule.
Power rule. Exactly. What's the power rule say?
Oh, is the A a constant?
A is all these a's are constants. Yes. What do? You take the what?
The 5 and put it in front of
The power on the x, and you do what with it?
multiply it by the
So when you start out with the derivative of p of x, you're taking that power, multiplying it by the constant, a1, keep the variable and do what with that power? Subtract it by 1. Then if I do the next one minus, I take that power times what? A sub 2, x to the what power? 2. And you just keep on going to all the terms until you do the derivative of this constant, which gives me a 0. So there is really a formal definition of the power rule, if you recall, that f of x equals to some constant, I'll call a x to the n. Well, so the definition of the derivative was, say the same thing again. Do what? Take the power of what?
multiplied by the constant.
Go read it to me.
Oh, is that a 7?
No, it's ax to the n.
Oh. N and A x to the n minus 1.
Perfect. So that's what you would tell somebody. If all you're doing was a polynomial, you'd have to do this to every single term, right? So to find the antiderivative, we need to do
Wait, go back to the formula.
No.
this one right here?
Yeah. Is that times AX?
Yeah, it's n times a times x to the, that power. So now we're going to do the antiderivative, which means we're going to do the opposite. So if I start out with, let's say, I wonder if I can do it from this generic one right here. I'm going to try. If my derivative was equal to an n times that constant a, x to the n minus 1, how would I get this back to the function?
Divided by n times.
Okay, divide it.
You have to divide by
Wait,
n.
what do we multiply?
I'm so confused.
Or root it?
You have to divide the n and then somehow like add the 1 on the x.
Well, could we add the 1 first?
Oh, yeah.
Because we go in reverse of the orders.
Already filled the joke?
It was a hit. The class loved it.
Okay, thanks.
Yeah.
One of them.
Yeah. They're actually saying you should quit your day job.
Oh, really?
Yep. So say it again, Yannick.
You have to add the 1.
So we add 1 to what? We take that x to the n minus 1 and I do what to it?
You add a 1.
I add 1 to it, then do what? Remember, I have an NA right here, so now do what next?
Divided by n.
And where's the n coming from? A minus 1 plus 1 actually is NAX to the n, right? So you said divide by the what?
The n.
The n. So technically I divide that whole thing by the n, same thing, and it cancels out, and voila, you're back to AX to the n. Now, sometimes I think that's more work thinking it that hard. I could probably easily give you f prime of x equals to 2x to the fourth, and I bet you there is at least half of you could tell me what the function had to have been.
That's
Maybe I'm wrong. Do exactly the same step that Yannick said. What did he say to do first?
Divide.
No, he did not.
yeah.
Add 1 to what?
The 4.
So what does that become?
5.
X to the 5. And I had the 2 sitting here. Next I do what? Divide by 2?
No,
Oh, I know.
I divided by
and
the n. So that is your function. If you don't believe me, go ahead and do the derivative of this function now. What did I do to go? I would take that 5, multiply it by the front, take 1 away, and what does that become? Which is what I had as my derivative that I started out with, and sure enough, it is. So get that in your head again. We, instead of taking 1 away from the power, we add 1 to the power. Instead of multiplying that in front, we divide by it. And what it's doing, it's undoing those operations we had.
so is it just finding the regular function?
You're finding the regular function. If you have f prime, your goal is to get f, going backwards. And the antiderivative is known as, this is how we'd write it. That stands for the integral of f of x, or the antiderivative of f of x. Now I know what you're thinking. What in the world are they doing here? Sort of like when we did the derivative with respect to x. That's what this means. It's the antiderivative of f, antiderivative of f with respect to x. And you're going to find out what dx actually means. It actually means something infinitesimally small, delta x small.
So if it says that, are we gonna have to do
Of just y?
Or like those.
As long as we were with respect to y, dy, yeah, you could.
But is that like a thing?
Yeah, it's a thing. Yeah. So in finding the antiderivative of a function, you are finding the original function that you took the derivative of. You're working backwards. This will enable you, even if f prime or f double prime, yeah, you could go backwards from the second derivative, you can go to the first derivative. From the first derivative, you go back to the function. If you want to do it a couple of times, you could integrate it twice if you want to get back to f. Let's say you're at the second derivative. To go backwards, you'd have to do the antiderivative 2 times.
Is there an easier function, like a way to do it?
Well, this is a pretty easy function.
Well, yeah, but is there like a formula for it?
Um,
Or is it just like we have to go back?
yeah, I guess so. If integrating ax to the n dx, then generically that would be ax to the n plus 1 divided by n plus 1. And there's something I haven't talked about. You're going to see that if it's a naked integral, we'll always say a plus constant, but that doesn't, you don't have to worry about that right now. The reason we say plus constant is, why am I going to tell you? Remember this problem that we tried out over here? What if I was doing a derivative of f of x equals the 2x squared that I had, but then I go plus 5? Wouldn't the derivative still be the same? Was it 2x? It was 2x to the, what was it? 2x to the 4th. Where'd I get the 5? Right? It was 2x to the 4th. So what if I got 2x to the 4th plus 5? Would that give me the same derivative that I just got a minute ago? Yeah. It would give me the same answer because the derivative of 5 is 0. So your answer could always have a constant in it. And right now, we don't know what the constants would be. Could be anything. A lot of answers. You could put plus 1, plus 2, plus 3, plus pi. But I don't think they're asking us to worry about that. They just want to worry about what I have here. Can you do that real quick? You think so?
What does that symbol mean?
This? It actually means this in you had in pre-cal. It's a summation. It actually means you're adding up. It's really a squiggly S called it's the integrand, I guess it's called, but it's really like an S, which means summation. You'll learn later why. What are we summing up? We are summing something up. So the symbol for summing up is this squiggly S. So if I was to do this one real quick, how do I do that first term?
X squared, x to the third.
Just x to the third? You didn't do any, how'd you jump to that answer?
You add 1 to the.
Okay, you add the 1 to the x, so that's a 3, yeah.
And then you put.
Then I divide that by a 3, but I already had a 3 here. Is that why it went away? Perfect. X to the third. Nice. How about the next one? Plus
Squared.
just an x squared because the 2 over 2 cancels. Great. Plus
3x.
plus a 3x. Yeah, that a lot of people get that one wrong, Julian.
Why?
I don't know. They have trouble with the 3.
Oh.
They have trouble realizing it stood for 3x to the 0. Add 1 to the 0. 3x to the 1. Divide by 1. Nice job, Julian. Not everybody sees that. And there's probably half the class in here still saying,
No, it's not.
yeah. You saw it too?
Yeah, she beat me to it.
Yeah, well,
I didn't know where the dividing part, like if we have to divide. Or
by 1.
by 1.
Yeah. All right. Now, what do you think happens? Because we don't know anything about a quotient rule with integration. So unfortunately, there's that rewrite you have to do because there really isn't a quotient rule for integration. You need to have the terms set up individually. So there actually is a product rule, and it's called integration by parts. But that's in Calculus BC. So we won't have to do a product rule per se. And for this one, there are ways of leaving fractions, but then that's going to be a more advanced method of integrating without having to change this around. There is an advanced method to integrate it, which we'll get to that in a few weeks. So I'm going to rewrite it first. Every term gets divided by x. This actually is probably the easiest way to do it. I'm sort of stuck with minus 4 over x. I don't want to leave it like that either.
You don't want to do the x plus x and negative 1?
Let's see what happens if I do that. Okay. I hope somebody yells at me and says, that was dumb, but let's see what happens. Negative 1. Let's see what happens here.
It's not, you don't have to add it if it's times, it's multiplied?
Yeah, it would be a 4 times x to the negative 1. That's right. If you're seeing something, right? You already see a problem, right? So this probably will be the hardest part of today's. She sees it. She sees a bad pitfall. So if you were to do the derivative, the integral from left to right, what's the first term become?
No, can we just go back to
Is
the
it
other
one?
one?
Is it one?
What other one?
The one where you had it over x.
What about it?
Can you just do that instead of the negative one? It doesn't look right.
Possibly, but you have to have, it may be something you have to memorize.
It's so ugly.
I know.
Because if you add 1 to the negative 1,
What happens to it?
it doesn't, right?
What's wrong with the negative 1 plus
It's
1?
gonna become a positive when it's.
Yeah, what's wrong with the 0?
It becomes 1. The whole thing, right? Because x to the 0 is 1.
Yeah, and so go ahead, keep going.
I don't know.
So you're saying there's no problem. Okay, let's move on then.
Become negative when it shouldn't be. I mean positive when it should be.
All right, let's get to it for a minute here.
Am I right?
No. X squared becomes what?
Is x to the cube?
Over what?
3.
3.
Wait, but sir, where did you get x squared from?
Wait, can you?
No.
You divided the...
Take 2 and add 1 to it.
Okay.
And then divide by it. The coefficient happens to be a 1 in front.
Wait, oh, okay.
Why'd you put a 3 in there?
Because we added 1 to the
It
2.
was an x to the...
It was an x squared.
It was an x cubed. Originally.
It was?
Yeah.
Oh, yeah, I'm blind.
No, but that's what you did say. You divided it all, no?
Yeah, but I thought it was a 2.
Yeah, but you divided
So-
everything by an x.
No, you're good, sir.
Oh, I did divide by x. Yeah, I was right. Yeah, it's not too often I can say that. I was right. So I stand by x cubed over 3, or 1/3 of x cubed. Or, x
Okay, yeah.
x cubed.
Yeah.
1/3 of it. Either way.
Like, unique. The first part, he just divided everything by x. Divided everything by x. When it was x.
So do you agree with this x cubed over 3? What happens to the plus 2? 2x. Because
The one we took when.
Because there was technically an x to the 0 here, right? This is the same one that Jillian figured out. Now, some of you say there's no problem. Minus 4 x to the x to the 0. And somebody back there said no problem. No problem, right? But don't we have to divide by this? Problem.
So it was a constant?
No. No. What we need to remember. All right.
Wait, sir, I have a...
So, yes.
Oh, never mind. I think I did.
Okay, I'm going to post this up and you can finish. So, let me ask you a question.
Wait, no, I have a question then.
Yes.
Why did you make it a 3 again? Like, the 1x?
Add 1 to the power
Oh, okay.
and divide by it. So I added 1 to 2, that made it a 3, and then I had to divide by it. Now, well, actually, it was down here. I already had that. X cubed divided by x, x cubed divided by x is x squared. When I integrate x squared, I have to add 1 to the power and divide by it. That's what happened.
Yeah, I get it.
All right, so let's take this negative 4 over x and just put the negative 4 on the outside and just talk about 1 over x for a minute.
1 over x.
Well, yeah, that's what negative 4 over x means. Negative 4 times 1 over x is negative 4 over x. Wasn't that the problem I have? Isn't that what's there? So I want you to look at this for a minute. The power rule didn't work. The power rule messed up miserably because you cannot divide by 0. I want you to stare at that for a minute and ask yourself, was the derivative of anything ever 1 over x?
Ln.
Oh my God, you're just a genius. So when I do the antiderivative of 1 over x, I cannot use the power rule. I have to say that that answer is negative 4 times the natural log of x. As long as, keep this in mind, that x was the bottom and the derivative of x was 1. Remember that du over u? Whenever you see du over u, then you knew that we were doing the derivative with respect to x of the natural log of u. You knew that we were doing this problem because I had a du over u, which is the answer to the derivative. And in this problem here, if I take that constant of a negative 4 out and leave it just as a 1, and I call my x as my u, the derivative of x is 1, perfect. Jillian nailed it. So over here, I'm going to get rid of that piece of garbage and write minus the natural log of the u, x. So I'll rewrite the whole answer. Equals to x to the third over 3 plus 2x minus natural log of x.
Oh, not a 4 natural?
Oh, yes, I'm completely messed up. Minus 4 natural log of x, yes. So that probably was the hardest thing because it didn't match up with what I was telling you to do. And I have to ask myself a big question. Why did the author throw that in? You know, it didn't match up with the power rule. But at least we got it out of the way if it comes up again. So I want you to think about whenever you see fractions, check to see if you have du over u. Yes?
How many units are there in calculus?
We have 6 is the biggest unit that we have left. And then if I even don't go and do 5, we'll be okay because a lot of stuff in 5 comes up here in the 6. There's a little bit in 7 when we start talking about finding volumes of revolutions or a volume of a solid on the desk, how to find the volume of it, where we cut it up into pieces. And so I'm going to say it's 6.5.
So we're almost done.
Yeah. But don't get me wrong, this unit is 30% of the test, so we got to really do well on it. It's all right. Okay, now I did that. That one, okay, somebody asked, there's no power rule right now. I want you to make this into a polynomial. Oh, you want to, what is that called? So instead of using a power rule, she's using a product right now. She's just going to multiply it all together. So her rewrite becomes, say it again, 2x squared?
2x squared.
Uh-huh.
Hold on, I need time to think.
Minus 3x plus 4x minus 6. You can leave it like that, but I know Jillian's not that way. She's going to say, I need to probably simplify that. But she doesn't have to. If she didn't want to, it'll still work out. 2x squared plus an x minus 6. Okay, now it looks really easy. I think most of you could probably give me the antiderivative super fast. Is 2 X what?
Over 3.
Over 3.
X cubed.
X cubed. You did it kind of reverse what I was thinking. I always do the power first, then say divide by 3, but yours is good though.
Oh, yeah.
Go ahead.
It feels like when it's like x squared, is it always just gonna be
X
that
cubed.
number divided by
3. Yeah. And guess what? If it's x to the 5, it'll always be x to the 6 divided by 6.
Incarnate.
Yeah.
what about x to the fourth?
I'm glad you asked. That'll be x to the 5 over 5.
So is it that for all even or all?
Polynomial terms. Yep.
So if it's let's say it starts off as x cubed,
Yes.
then is it the number divided by?
It's 4 over 3.
Yeah.
X to the 4 over 3. Right? Or over
No,
4?
it's still a-
Over 4.
It's over 4.
Yeah.
Once you add 1 to the power, that's what you divide by.
So it's so it's always gonna be like is it that's how it works for every single
For polynomials.
for polynomial.
Yeah. Algebraic terms. Yeah.
So what have we been doing?
Well, we just threw in a natural log garbage right now, so it has nothing to do with the algebra. So he threw that in there to make us sweat. I was sweating. I had bullets of sweat coming down saying, oh my God, how are we going to get out of this mess? All right, next one. The X.
I'm confused.
Me too.
Squared over two.
Yeah,
Oh, yeah, you're right.
Wait, what?
I'm getting it now.
Oh, okay, I get you.
Because there's an invisible 1 power.
Minus 6x.
Minus 6x. Wow. And get in the habit that there's also some constant that it could have been, because you could put any number there and do the derivative from left to right. You're going to get the same thing as you started out with.
So do we always have to put plus constant?
He's not pushing it, but yes.
On the AP, you put plus constant.
If you're doing this integral that has no numbers with it, because right now we call this, I don't want to bore you with facts, but yeah, if there is a constant. Because to check your work, you'd have to do the derivative with respect to x of your answer. 2/3 x cubed plus 1/2 x squared minus 6x. Well, when you do the derivative of this, it needs to come back to, I'll circle this. You have to get when you do the derivative of this, it has to be this. But if I had a plus 4 here, it still will be the same answer.
What's 2/3 times
2.
3? Whoa. I knew that.
All right. How about this one?
Do we make it a product do we make it like a polynomial?
Yes, well, since it has a rational exponent, it's not called a polynomial, but it's polynomial-like.
Yeah.
Yeah, so how would I change that?
2 times
2.
x to the negative 1/2.
Beautiful job. So now, take your time. I need to add 1 to a half.
3/2.
So I have my 2, I have my x, and you're telling me it's 3/2, right?
Yeah. Wait. Yeah. Half.
Oh, I thought I heard you say 3/2.
No, I messed up.
Okay, so you're telling me it's a half.
Over.
So now I got to divide by a half, and here's how I do it. When I divide by a half, I do 1, 2 on top.
Oh, because it just multiplies.
Because I'm multiplying by the reciprocal. So I go, when I divide by 1/2, and I'll erase that step to show you, if I divide that by a half, it's the same thing as taking 2x to the half times the reciprocal of half, which is 2 over 1. So to me, it just makes more sense to say 2x to the half, divide by 1/2, and put the denominator up there, and you get the same answer. 2 times 2 is 4 square roots of x. And you can say plus c, so 4 square roots of x plus c is a perfectly good answer.
Can you zoom back in real quick?
Do what?
Can you zoom back in?
And if we were allowed to give you guys homework over spring break, I'd give you 100 integrals to play with.
Okay, sir.
No, you know what I used to give? I used to actually give your first full AP exam during spring break when I was working for other places. And on that test, you would find out that even as of right now, you're almost passing the AP test. You're this close. With the knowledge that you have, you're this close to passing an AP test right now, today.
You're iconic.
Stop it.
So, sir,
I saw you talking to Mr. Flores. He's iconic
No. You're much more iconic.
so
in my own head.
after like April, we're gonna just start prepping.
Yeah.
AP.
Yeah. Well, we need to get through a couple full AP tests.
How many?
I'd like to do one with you, and then I'd like you to do one on your own.
Like with us, meaning like we'll all.
Yeah, we model it. We work out each problem together. Like, you know, you do a couple problems, and I'd go and follow through with those two problems, show you what I think stands out. Yeah, right. Go ahead. It's already signed. That's my goal, but you, huh?
When?
When? Well, Brown, yeah, we got to get through March, and which is not got to get through March and sometime in April. We got at least a couple weeks where we need to just hopefully call it what we have and see what we can do. All right, here it is. We have learned that the derivative of sine is cosine. We have learned that the derivative of cosine is a negative sine. So now, knowing this information, this is sort of like when I asked you, do you remember the derivative of something was equal to 1 over x? And then it was Jillian who said, oh, the derivative of ln of x was 1 over x. So I'm telling you that the derivative of sine is cosine. So if I'm integrating cosine, if I integrate cosine, what do you suppose the original function would have been?
Negative sign.
Sine.
It would be sine. That's right. Because look what's here.
Oh, I got
Now it gets hard right here. If I'm integrating sine,
Negative cosine.
why? Where are you getting the negative from? Okay, yeah, I'll take it.
Because
Thank you. I'll do that.
sine should be negative.
Right, because there's this blasted negative here, has to go somewhere, doesn't it? So when you say that the integral of sine is cosine, but really you needed to have a negative sign to get the cosine. So you're right, negative cosine. Okay, so how do I remember this? Remember when we said the derivative of sine is positive cosine, and the derivative of cosine was the negative sine. So now it reverses. The integral of sine is negative cosine, and the integral of cosine is positive sine. It reverses which one gets the negative. I mean, you can look at it that way. So if I'm doing from left to right, what is the integral of sine?
negative cosine.
Okay, so this is going to become a negative 2. The constant just comes with it. Cosine of x plus what?
Cosine.
Plus what?
Sine.
Sine, yeah. And I still have my constant that I like to play with there. Go to the right. Let's see. Oh, combinations. Left to right. T
T to the third.
divided by,
3.
you finally have it, Yannick. Minus what?
Cosine.
Minus cosine. Yeah.
Minus cosine or minus cosine?
No, minus cosine.
The derivative of sine is
Oh,
cosine.
plus cosine.
It becomes the, yeah, so that, cosine, so that turns into t cubed over 3 plus, like you said.
No exponent?
Nope, not with this, no, not with this piece, no.
Would there be if it said like in the first example, it says 2. Oh, never mind. The x is.
It was a coefficient.
Okay.
All right, do another one. Left to right, 4x becomes what?
4x squared.
Yes, 4x squared over 2. And I realize I have a rewrite I could do after I'm done, but I didn't want to sweat it, okay? And y plus?
Because the derivative of
Cosine is the derivative of the integral of cosine is a positive sign. So that negative stays there?
Yeah.
It does stay there.
Yeah.
Now, if you want to make it prettier, you would call it x squared with a 2 in front, minus 3 sine of x plus e. And, oh, we kind of did the square, no, we didn't do a square root like that before.
We did it under
We had it under. How's it different now?
the top.
So I would write it as x to the 1/2 plus sine of x. Let's see if that stumps you.
X to the 3/2.
Yeah, x to the 3/2. Watch me. Divide by 3/2.
So it's times 3 divided by 2.
No, times 2 divided by 3.
Minus cosine x.
Oh, yes, minus cosine of x.
Wait, but if you have to divide by 3/2.
Which means multiply by 2/3, right? Reciprocal. So that was a pretty big mouthful that we have just practiced on. I mean, I feel like, wow. What does he jump? This guy who writes this stuff, I mean, it's good because it makes us, every lesson is connected to other things that I'm not expecting. Use the given information about f prime and f double prime to find f of x. I don't have f of x here. So I start with f double prime, and I will antiderivative f double prime to give me f prime. Does that make sense? Yes. Then I will antiderivative f prime will give me what? F of x, which is what I want. So let's start with this. What is my equation for f double prime? So I'm going to go simply integrate 2 dx. I add that dx. The integral sign and the dx go together like a sandwich. So when I integrate 2 dx, what do I get? 2x divided by what? 2x. But remember what I told you? There's this constant. Am I going to need that? Let's see. He told me, now what does this become? This is my f prime, right? He's telling me that f prime at 2 is 5. This is my f prime. I need my f prime at 2, meaning I take my 2 times the 2 right here, plus my constant equals to 5. Why am I doing this equation?
So you can figure out the
Which constant did he have? Exactly. So what constant did he have in his original f prime?
1.
You're right. Well, that's why she said 1. I was ignoring her because I thought, I don't know what she's talking about. C is 1. So what I have to do now, I now have to integrate 2x plus 1 dx. This is my f prime, and I want to make an f out of it. So what am I doing? I'm integrating this whole thing. And when I integrate this, what do I get? This is my f now. What am I getting?
You get 2x divided by 2.
2x, just 2x
Hold on.
Sir, can you help me with a question?
Yeah, 2x squared.
divided by 2
Yeah.
plus
Plus c.
x plus the constant.
Where you get the x? Oh, yeah.
Yeah, it's 1 times x to the 0.
Plus x plus c.
Mr. Cartwright,
Yeah.
can you help?
I don't know, Cassie.
I keep replaying
Sir,
it.
can you tell us your
like redoing this in my head and I get the same answer every time, and the answer isn't on the answer. Like, it's not there.
It's not there. Maybe it's a bad quiz.
I don't know, like, okay, look, sir.
Right there's a pass. Did the last person come back?
So, let me walk you through the steps here.
Wait, I gotta stop recording you.
Oh, sorry.
Oh, we gotta find F. Well, I have F, but it has a constant in it. Did he give me any information about F? He certainly did.
Sir, wait, how did you get C, the constant equal to 1?
No, the x integral of x of 1 became x. You always have a plus c.
But why C equals to 1?
Oh, up here, because we had 2x plus c, right? He told me up at the top that the first derivative at 2 is 5. So I took the first derivative. This is the first derivative at 2, which gives me 2 times the x, which is 2 times 2, plus that constant, has to be 5. I just solved it for c. 2 plus 2 is 4. 4 plus c. Take away 4 from both sides. C is a 1. So that created the whole equation of the derivative. So I wrote the whole equation of the derivative right here. Then I integrated that equation, giving me x squared, basically x squared, because the 2's are going to cancel, plus the x, plus another constant. Now, this constant here is really technically a different constant than the one that was up here. That's a different constant. That's a different one. So anyway, this is my F, is this. But I got to find out what the constant is. So I go up here, and he tells me that the function evaluated at 2 will always be a 10. So I go here and I say, the function evaluated at 2 will always be a 10. So I'm going to plug in a 2. So that gives me 2 squared plus a 2 plus that constant. That gives me 4 plus 2 is 6. 6 plus the constant still is 10. This constant must be a 4. So the actual equation of f, the full equation of f of x, would be my x squared plus x plus the 4.
Okay, I get it now.
It's a lot. This is heavy.
You're uploading this, right? The video?
Yes, the video is recording. I will upload it. Send the tips to my PayPal with my email address, and I'll appreciate it. All right, let's do another one of these ugly things. We're starting out with the second derivative. We're going to integrate that to get the first derivative. We integrate that to get the function. Each time I integrate, I always introduce a constant. Cassidy, you're cheating.
I already turned my quiz.
Oh, you're not cheating. All right. So, oh no, it's going to be live for everybody to hear you.
Oh, really?
Yeah, we're recording.
I wasn't cheating.
She was not cheating.
He just randomly accused me.
I randomly, wasn't random, I purposely picked you. Randomly would have been, close my eyes and say, Alfredo, you're cheating. Yeah, that would have been random. I purposely picked on you. All right. So integrate x to the negative 3/2 dx. This is going to give me my f prime.
X to the negative half.
How'd you get that so fast?
I was thinking about it way before you started.
All right, you take the x, you add 1 to the negative 3/2.
Divided by negative.
That gives me,
So is it times negative 2?
well, when I add 1 to negative 3/2, what does that give me? Doesn't that give me a negative half?
Yeah.
Divided by a negative half?
So isn't that times 2?
Go over the square root of x. I don't get it.
Okay, well, yeah, I'm gonna leave it like that though. I might rewrite plus my constant. You want to change it? I'll change it to this. Negative 2x to the negative 1/2 plus my constant. What, you wanted to change that to 1 over the square root? Is that what you wanted?
That's what she wanted.
Okay, negative 2 over the square root of x plus my constant. All right, so that's my f prime. And I go up here and realize, look what he said. F prime at 4 will always be a 2. So this is my f prime. This is my f prime right here. So I'm going to take my f prime, evaluated at 4, should be a negative 2 over the square root of 4 plus my constant has to be how much?
4,
Nope,
2.
a 2. Has to be a 2. So I do very careful, and I try to solve this. What's negative 2 divided by the square root of 4?
Negative 1.
Negative 1 plus my constant is 2. My constant must be a 3. So my f prime is really, I'm going to integrate my f prime, which is really going to be 2x to the negative 1/2 plus the 3. Why did I leave it with the exponent on top? So I could do my antiderivative again. Because right now, this will be my f. When I integrate my f prime, I'll get f. So what's the integral of 2x to the negative 1/2? Add 1 to negative half. A half? X to the half divided by 1/2.
So it's times 2
That's right. Plus
plus, hold on,
3x. Plus
C.
a constant. This is my f, guys. This is my f with a constant. But that constant could be anything, but not in this problem because f of 0 is, oh, okay. So f of 0 would be 2 times the square root of 0 plus 3 times 0 plus a constant has to be 0. So what's my constant for f?
Wait,
0.
My constant is 0. So my real f of x is 2 square roots of x plus 3x.
sir,
Yes, sir.
when it's the 2x to the 1/2,
Yes.
don't you multiply a 2 to the 2?
I did.
You forgot the 2 on top, sir.
Yeah, the 2
Oh.
on top,
It's not the 2 yet.
2 times the square root of x. It's right here.
No, but there should be a 2 times the 2 x to the 1/2.
Because it was 2x.
Oh, 2. There was times another 2.
Yeah. Sir, I think that's,
Oh, yeah, you're right. So that's really a 4 then, right?
yeah.
A 4? That's really a 4? It was. Thank you.
Extra credit or what?
Yes, Yannick. Yannick. Extra. All right. Those are hard, guys. If I was to watch anything at home on this video, I would watch those two. Is there anything else? It's there. No, I took it already. And then if I did have it, I couldn't even give it to you though. I'd have to just show it to you and say, yes, I have one, but I can't give it to you. Ha 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 ha. I'd lose my medical license.
You have a medical license?
No. All the more reason why they don't want me to have one. You're thinking about giving it to a teenager? All right. A evergreen nursery usually sells a certain shrub after 6 years of growth. And of course, they're doing a lot of shaping it. Julian,
I'm sorry, what?
how long do we keep the shrub before we sell it? 6 what? Years. Okay. The growth rate for those 6 years is approximated by this differential equation. It's a derivative. But don't let this scare you guys. This is no different than dy dx.
Why?
It's a derivative.
Why?
But what I want you to do for a minute, I want you to pretend that I could multiply both sides by the dt. Okay? I want you to realize that this means the change of height of the shrub is equal to 1.5t plus 5 dt.
What?
I multiplied by this denominator. That's typically what we do with the differential equation. Now, my calculus teacher in college would get mad at me for saying that I multiplied both sides by dt. You really did not do it. what we really did is called separating the variables. I separated the dh and the dt so that I could put the dt with the function. But for you and I, normal people, it looked like I multiplied both sides by dt. But in math talk, we separated the variables. Now, you might be asking, why would I do that? Because look what he's saying. Time, t is in years. Height stands for height in centimeters. The seedlings right now are 12 centimeters tall. That means this, guys, when t is equal to 0, when I buy my plants, my shrubs, they're already, the height is 12. I wonder if that stands for an initial condition like we did at the top, where when x was 0, y is equal to 12. I wonder if we could think of it like that. But anyway, find the value of the differential equation above when t is 3. So when t is 3, find the value of the differential equation. I just plug it in, that's right. If he just wants to know what the differential equation is, if I just left it as dh dt and plugged in the 3, at 3, I'm going to put t is 3. Would that look like 1.5 times 3 plus 5? What does that give me? Yeah, it would. Try harder.
It would be a 4.5
Plus
9.5.
9.5. What would the units be? It's a rate. Just like, remember your related rates? What does dh dt mean?
Centimeters per year.
Height per
Year.
year. So what's the variable of height?
Year.
Centimeters per year. I heard it. Thought I heard it. So in other words, as the shrub is growing, the change of height when the time is exactly 3 years, if you could stop time, the shrub was growing 9 centimeters per year at that very moment.
Wouldn't that mean that for 3 years?
In 3 years, that's the rate it's growing. Every year it's growing 9.5 centimeters at that moment. Now remember, it already was 12 when we bought it. So what do you think, how high is it right now in 3 years exactly? Roughly, can you estimate it? 21, yeah, plus the 12, right? Because we already had 12. So that's an estimation. Now, mind you, year 1, it may not have been growing that fast. Year 2, it might not have been growing that fast. Year 3, it was growing that fast. So you're taking the maximum speed right now and using it for all 3 years. So it's just it might be an over approximation. What else did he want? For the equation for h of t, wait, I have an equation for, well, I don't. Do I have an equation? No, I got to find it. Interesting. I wrote this up here. dh equals to 1.5t plus 5 dt. How could I get an equation for h out of this? Say it again, louder. If I integrate the left, what do you suppose when you integrate dh, what do you think comes out? When there's an imaginary 1 here? H. Nice job, Thomas. That's extra credit. So yeah, when you integrate dh, there's an imaginary 1. The variable was h, so it comes out to 1 times h divided by 1, basically. So h of t is the equation. But you can't just integrate the left. You have to integrate the right. And what happens when I integrate that?
It would be 1.5t squared divided by 1.5.
Nope, divided by 2.
Divided by 2.
Plus
5t.
5t plus C, right? Well, I don't want C in there forever. Can I find the exact constant that the height function was? Do I have any information about the initial condition? Yeah, I know that when time was 0, the height was 12. H of 0 is 12. Yes or no?
Yes.
Is that just like what we just did up the top?
Yeah.
So I got to plug in a 0. What happens when I plug in a 0 into this?
0.
0. What happens when I plug in 0 into this?
0.
What happens when I plug in a 0 into C?
C.
C. So what is C?
12.
C is 12. So what is my height equation for real? Height equation for real is
1.5
1.5
over 2
t squared over 2, right?
plus 5t.
Plus 5t plus 12. Now, I can ask the question better. How tall was it really in 3 years? How tall? You had an estimate. You gave me an answer, 21 something, right? I wonder how close you were. And I told you I think that's an over because that rate of change stood for 3. It could have been slowing down or speeding up. I think as a tree grows, it probably gets it probably grows slower at first, then seems like it gets bigger. But I'm just guessing. So if I take 3 and plug it in, you might have to use your calculator. 3 squared is 9. Can someone do 1.5 times 9 divided by the 2, please? 1.5 times 9 divided by 2?
6.75.
Okay, hold that. Add that to 5 times 3, that's a 15. Add that to 15.
21.75.
Plus 12.
33.7.
Oh, actually, we were under.
Yeah.
It's actually 33. Unit?
Centimeters.
Centimeters. Right, centimeters.
Oh, just not for you?
No, because this is just h, the height. That was exactly centimeters. So when t was 3, we have a height of 33 exactly?
No.
33.75.
Oh, 0.75 centimeters. Is it ready to cut? Well, no, because we got to grow for 6 years. Hey, wonder what this would be if it went 6 years.
Probably the double.
Probably that, but doubled, probably. Yeah, maybe it is. I'm not going to figure it out, but. All right, last thing. You do know your relationship between derivatives, right? If a function is moving, f of x, that's a position. How high is it, right? What is it called when I do the derivative? Position turns to what? It's velocity. What's the second derivative? Acceleration. What's the third derivative? I want to make a shirt for this, though. Velocity, acceleration. What's after acceleration? Third derivative. It's called the jerk.
The jerk?
It really is. So I might make a. Wow, never thought I'd see that. I'll never get that out of my head again. I gotta go home and pour some bleach in my ears. Now, so I'm gonna make a shirt that has the third derivative. Say, you are the third derivative. You know. Yeah, just walk away. No, I'm not gonna do the dance. Only Cassidy can do that. All right. So look at here, guys. All right, I can tell we're not interested. Let's see. If the homework has this, I got to. Yeah, it is the last. Teach it. If the homework doesn't have it, I won't. By law, I have to say it's due tomorrow because I can't assign you homework over the spring break.
But by, the technicality is due when we come back.
Teach it right now.
We worked pretty hard.
You luck. I am going to cover it when we come back, but you got a homework, and I got to. By law, I have to tell you it's due tomorrow. Okay, you're.